Hi everyone, welcome back to Chem Help ASAP. Before we jump into all of the math that is stoichiometry, we first need to learn how to balance our chemical equations. So brush up on all those counting skills you learned in preschool because we are going to need them. This really is as simple as counting up atoms on either side of the equation and making sure they match. So here is a generic equation. We're going from reactants to products. And these small letters here are the ones we are trying to figure out in our equation. These are called your stoichiometric coefficients. Generally, I move from left to right, so I'm going to start with my sodium atoms. I see I have one sodium atom on my reactant side and one sodium atom on my product side, so they are balanced. Next, I'm going to take a look at oxygen. I have one on my reactant side and one on my product side. They are good. Now for hydrogens, notice I have one hydrogen here and one hydrogen here, so I have a total of 2 hydrogen atoms. But notice in my water, I also have 2 hydrogen atoms, so my hydrogen atoms are balanced. Finally, I need to look at my chlorine atoms. I have one on my reactant side and one on my product side. All of my atoms are balanced as is, therefore I do not need to write in any stoichiometric coefficients. If there is no number written in front of an element, it is assumed that there is a 1 there. So for this equation, all my stoichiometric coefficients are 1s. But not all equations are going to be 1 to 1. Let's take a look at my second equation to balance. Again, I'm going to move from left to right. So I start with my calcium atoms. I have one on my reactant side and one on my product side. Okay, calcium's good. Chlorine, I have 2 on my reactant side, but you can see I only have 1 on my product side. So to balance my chlorines, I am going to put a 2 in front of lithium chloride. Notice I do not balance with a subscript 2. That is not allowed. That changes the molecular formula. Balancing chemical equations must always be with coefficients in front of the compound. Moving on to lithium, I have 1 on my reactant side, but I have now 2 on my product side. Therefore, to balance these, I am going to put a 2 in front of my lithium fluoride. Now lithiums are balanced. Finally, my fluorine atoms, I have 2 on my reactant side and I have 2 on my product side. Let's move on to my next equation. Again, I'm going to move left to right. I have 1 aluminum atom on the reactant side and 1 on the product side. Great. Hydrogen, I have 1 on the reactant side, I have 2 on the product side, so I will put a 2 here. Chlorines, I have 2 on my reactant side and 3 on my product side. This is going to be very difficult to balance with a whole number. So when you find yourself in a situation like this, I want to show you a trick. One thing that I do is I go ahead and just erase my stoichiometric coefficients, erase everything here, and I'm going to start over and I'm going to put a 2 here in front of the aluminum. So I have 2 aluminum atoms on the reactant side and I'm going to have 2 on the product side. Now if I take a look at my chlorines, you see I have 2 times 3, I have 6 chlorine atoms. I can easily balance that on the reactant side with a 6 here. Now my chlorine atoms are balanced. However, of course, I'm not finished yet because I haven't balanced my hydrogen atoms. But I have 6 on the reactant side, so if I put a 3 here, I also have 6 on the product side, and now this equation is balanced. If you ever find yourself getting stuck when you're balancing chemical equations, sometimes it's very helpful to erase everything, put in a multiplier of 2, and try again. For my last reaction, we are going to balance a combustion reaction. Very often it is hydrogen and oxygens that are the most difficult to balance. So if I can, I like to save those for the very end. Also, I notice in this reaction that oxygen is by itself here. This means I can put any number in front of that O2 and change only the oxygens. I'm not going to change any other atom. That's also one that I want to save to the end to balance. So for this combustion reaction, I'm going to start by balancing carbons. I have 6 carbons on the reactant side, so I need a 6 here. I am going to go ahead and balance hydrogens because I'm saving oxygens for last. So I have 6 hydrogens on the reactant side, and right now I have 2 on my product side, so I need a 3 here. So far so good, right? I have 6 times 2, that's 12 oxygens here. 3 times 1, I have 3 oxygens here. This gives me a total of 15 oxygen atoms. So the question is, what number do I put in front of my O2 here to give me 15 oxygens? Well, you can put in 15 halves. 15 halves times 2 will give you 15 oxygens. However, many instructors do not want you balancing with halves. So if you run into this situation, the easiest thing to do is multiply everything through by 2. So I will put a 2 here. 15 halves times 2 just gives me 15. 6 times 2 is 12, and of course 3 times 2 is 6. Let's double check and make sure that we have a balanced chemical equation. Carbons, I have 12 here. And yes, I have 12 on my product side. Hydrogens, I have 2 times 6. Again, I've got 12. Hydrogens on my reactant side, I have 6 times 2, which is also 12. Now for those tricky oxygens, I have 15 times 2, or 30 oxygens on my reactant side. Oxygens on my product side, I'm going to have to add up. I have 12 times 2, which is 24, plus 6 times 1, which is 6. This gives me a total of 30 oxygens. Yes, everything is balanced. Somehow I don't remember counting being such a challenge in preschool, but maybe that's because blocks are a lot more fun to count than atoms. Now that we can balance even our toughest chemical equations, we are going to take those skills and apply them to our stoichiometry in our next video. So I hope to see you there.